Our learning target for today is to use our prior knowledge about algebra, just like we did before, and we're actually going to be applying and using the midpoint and distance formula. There's going to be a lot of things that might seem familiar to us that you guys have done, in whether it's in other units, in previous years, that are going to seem similar, but keep in mind, like, we're still working with coordinate geometry, so we're dealing with a coordinate grid and coordinate points and all of that stuff. So don't lose what we did last week, and that will be built in today's lesson. So you guys can at this point follow along on the note sheet if you have it printed. And I am going to be going with that. So the first thing we're going to look at is the midpoint formula, and we're going to watch a short video on it.
What's up, everyone? Let's go ahead and start off this lesson on the midpoint formula by asking ourselves, what is a midpoint? If you had an 8-inch sub, the midpoint would be the location where you would cut it in half to make two smaller 4-inch subs. Now we can extend this thinking to finding the midpoint of a line segment that connects 2 points by finding the point that is directly in the middle of the line segment such that it cuts it into two congruent halves. In this case, you have line segment JK. Point M is directly in the middle so that JM is one half, KM is the other half, and they are both congruent. Ooh. Now we're going to be concerned with finding midpoints on the coordinate plane. So we want to think of a midpoint as a location with XY coordinates. And our tool in this lesson for finding the midpoint is going to be the midpoint formula. So let's go ahead and learn how to use it. Our first example wants us to find the midpoint of line segment AB, and it's giving us the coordinates of both endpoints. So let's start by plotting those endpoints, A at 7, 3 and B at -5, 5, and then constructing line segment AB. So we want to find the midpoint of this line segment. Again, we want to find the XY coordinate that is directly in the middle of this line segment such that it cuts it into two congruent halves. Let's go ahead and write down the coordinates of A, our first point, at 7, 3, and B, our second point, at -5, +5. And now we're prepping ourselves to substitute the right values into the midpoint formula. Now endpoints A and B are just XY coordinates. Since 7, 3 was the first point, that's going to be the x1, y1. And since -5, 5 was the second point, that's going to be our x2, y2. Now on the left side, x1 plus x2 is just going to be 7 plus -5. On the right side, y1 plus y2 is just 3 plus 5. We can continue to evaluate 7 plus -5 equals +2. Over on the right side, 3 plus 5 just equals 8. And finally, 2 divided by 2, or 2 over 2, is just 1. And over on the right, 8 divided by 2, or 8 over 2, is equal to 4. So using those two endpoints in the midpoint formula, we have found the coordinates of the midpoint of line segment AB at 1, 4. Oh yeah! Now our final example is slightly more advanced than the example that we just completed. This question is not asking us to find the midpoint, it's giving us the midpoint of line segment TN at -3, -4. It's also giving us the coordinates of one of the endpoints, this case T, with coordinates -6, -9. What we want to find is the coordinates of the other endpoint N. So let's visualize what's going on here. We know where the center of the line segment is, and we know one of the endpoints. We want to find the other endpoint N. So we know that endpoint T has coordinates at -6, -9. That's our x1, y1. And our other endpoint N has unknown coordinates, but that's still going to be our x2, y2. Now we're still going to use the midpoint formula, but we know that it's going to equal the midpoint, which we already have, which is -3, -4. So we'll start with the x-coordinate of the midpoint at -3, so we know that -6 plus some unknown number divided by 2 would have to equal -3. Solving this algebraically shows us that the unknown number will be 0, since negative 6 plus 0 is just negative 6, and negative 6 divided by 2 does equal negative 3. So what we just did was confirm the x-coordinate in the midpoint, the negative 3's, both match up. And we know that the value of the x-coordinate in endpoint N is 0. Next, we want to find the value of y2 in endpoint N. Now we know that the y value in the midpoint is negative 4, so we just want to find negative 9 plus what unknown value divided by 2 is going to equal negative 4. When we solve this algebraically, we should get positive 1 for that unknown value, since negative 9 plus 1 is equal to negative 8, and negative 8 divided by positive 2 does equal negative 4, which does match up with the y-coordinate from the midpoint M, and so we can say that the value of y2 in endpoint N is positive 1. And now we can plot the other endpoint N with coordinate 0, 1. Plotting this point allows us to construct the line segment TN with midpoint M at negative 3, negative 4. Now we'll finish up on a quick note on a visual method using slope. We notice here that the slope from endpoint T to the midpoint M is up 5 over 3. So if we repeat this slope from the midpoint going up 5 units and over to the right 3 units again, it will take us to our other endpoint N at 0, 1. Please follow us on Instagram.
Awesome. So hopefully that made a little bit of sense. I'm going to be reviewing that and summarizing it and, of course, doing some examples. So let's go ahead and turn to our note sheet and fill this in. So to find the midpoint of two coordinate points, you are finding the point halfway between two given endpoints. Ooh, that's not very neat looking. Right, so that's the idea. Like, you're finding the point halfway between two given endpoints. Right, so in order to do that, you are going to average. Remember doing mean? Average the x and y values, right? So the formula ends up being x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Keep in mind that your final answer is going to be a point, right? And so this is going to be that your endpoints are x1, y1, and x2, y2. So before I do any examples, I want to do distance formula as well so that we can kind of put it all together. So we're going to watch another video by the same guy, I like him, about distance formula. So this will be a few minutes as well.
Let's start off our lesson on the distance formula by asking ourselves, what is distance? We can think of distance as a length between a starting point and an ending point, just like a starting line and finish line in a 100-meter dash. When we use the GPS, we're looking at distances between a starting point and an ending point.
Starting route to San Francisco.
Just like the drive from San Diego to San Francisco would be a distance of 502 miles. So for this lesson, we're concerned with finding the distance between two endpoints connected by a line segment. In this case, line segment CK. If we measured this line with a ruler, we could say that CK has a length of 13 centimeters.
Ooh.
And we are going to extend this idea of finding distance between points on the coordinate plane. Please note that distance is a measure of length, the words are interchangeable, and distance is measured in units. Finally, when finding distances on the coordinate plane, Our tool is not going to be a ruler, but the distance formula. So let's go ahead and learn how to use the distance formula. Our first example calls for finding the length of line segment AB. Now, when we see the word length, we should be tipped off to use the distance formula. First, we're going to need the coordinates of the endpoints A and B, with A at 3, 7 and B at 7, 4. Now again, A and B are both points with x and y coordinates. Since A is the first point, we'll give it the 1's x1, y1, and since B is our second point, we'll give it the 2's x2, y2. And now we're ready to use our formula. Let's start off by looking at x1 and x2. x2 is 7, x1 is 3, so we have 7 minus 3 in parentheses on the left side of the equation. Now we can slide that over and look at y2 and y1. y2 is 4, y1 is 7, so we have 4 minus 7 in the parentheses on the right side of the distance formula equation. And now that we're done substituting, we can begin to evaluate. 7 minus 3 we know is equal to 4. On the right side, 4 minus 7 is equal to negative 3. Now we can evaluate the exponents. 4 squared is equal to positive 16. And we're adding that to negative 3 squared, which is equal to positive 9. Remember, a negative number squared is a positive value. And we know that 16 plus 9 is equal to 25. And finally, we can evaluate the square root. The square root of 25 is equal to 5. So what we just found is that line segment AB is 5 units long. Now, real quick, if we look at AB as the hypotenuse of a right triangle, we notice that the legs of the right triangle are 3 and 4. This is your classic 3, 4, 5 right triangle, and this value of 5 can also be found using the Pythagorean theorem, so we should see that the distance formula actually comes from the Pythagorean theorem, a squared plus b squared equals c squared. For our next example, we're going to be observing a quadrilateral on the coordinate plane with endpoints W, Y, C, and M. We want to find the length of line segment WC, so we know we're going to have to use the distance formula again. Notice that W and C are diagonal from each other, so this is a diagonal of this four-sided figure. So we have to construct that line to help us visualize what line segment WC looks like on the coordinate plane. Now we can write down the coordinates of W at negative 6, 4, that's your x1, y1, and C at 4, negative 2, that's your x2, y2. In the distance formula, we can now substitute x2 minus x1 is going to be 4 minus negative 6. Then on the right side of the distance formula, y2 minus y1 will be negative 2 minus 4. So now we can continue to evaluate. 4 minus negative 6, the double negative becomes a positive, so 4 plus 6 equals 10. And on the right side of parentheses, negative 2 minus 4 is equal to negative 6. Now the exponents, 10 squared is equal to 100, plus negative 6 squared is equal to positive 36. And 100 plus 36 is equal to 136. And now we just need the square root of 136, which is going to equal an irrational number. And since the question asks us to round to the nearest 10th decimal place, we'll round our answer to 11.7, the length of line segment WC.
Oh, yeah!
Please follow up.
Awesome. So let's fill some of that information in, and then let's do some practice and examples together. So again, into your notes, fill in your notes. So to find the distance between two coordinate points, you are finding the length, right? So the formula that we have, or that they gave us, was the square root of x2 minus x1 squared. And note, whenever you square something, it's always going to be positive, plus y2 minus y1 squared. So it's the difference of the x's squared plus the difference of the y's squared. And this is going to give us the distance, or the length, between 2 points. the other thing that they talked about was actually using the Pythagorean theorem. You guys have done quite a bit of work over the last, probably just more than just this year, with the Pythagorean theorem, where you had a squared plus c squared. Whoa, that's not what you have. A squared plus b squared equals c squared. And so if we do have it, like, you can always create that right triangle. And let's say you're trying to find the distance between these 2 points. And the idea is that it's the change of x. Oh, that's your horizontal value, right? So like this is going to be x2 minus x1. And then the vertical is going to be y2 minus y1, right? That's your change of y. Oh, that's why it's going to work like this, right? Like this is A and this is B, right? And this is C. But it's going to be when you square these and then take the sum and then take the square root. So we will go on to some practice with that, but you have now the distance formula and the midpoint formula, which I'm going to keep on the page as we move forward. So let's look at those first 2 examples on the front of your page. So I did one with a graph and one without. And over here, I have the distance formula as well as the midpoint formula for easy reference for us. So given AB below, find the midpoint M and the length of the segment, right? That's going to be distance. So to find the midpoint, let's identify actually what these coordinate points are, right? So B is actually 4, 3, right? Over 4, up 3. And A is -3, -4. So remember that I'm going to be averaging the 2 x's. So I've got 4 plus -3 divided by 2. And -4 plus 3 divided by 2. Right? So when I do this, 4 plus -3 is 1. So that's going to give us 1/2. -4 plus 3 is -1/2. And I would leave it like that. I would say 1/2, -1/2. And you can even go on to this picture and see, does that make sense? If I go if I go 1/2, -1/2, I get a point right here. That's M. Yeah, that looks about right? That creates 2 equal or congruent parts. The next piece that we're going to go on to with this is finding the distance, right? And so I have this distance formula, and I could also even go ahead and look, I can connect A and B and form a right triangle. What's this distance? 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6. Whoa, 7. It's isosceles, right? And oh, look, that's a right triangle. I can just use the Pythagorean theorem. 7 squared plus 7 squared is going to equal to the length of AB squared. 49 plus 49 is going to equal to AB squared. Is that 98? Yeah. Equals to AB squared. And so my final step would be to take the square root. I would probably leave it as the square root of 98, but I know we're not always super comfortable with that. So let's go ahead and see what that is when it's rounded. I'm getting about 9.899 is what I'm going to go with. Right? If you are someone that wanted to plug directly into this distance formula, by all means go ahead, right? Even, I encourage you to do that and see, did you get the same thing as me? Right? You probably would have done x2 minus x1, so maybe you did 4 minus -3 squared plus 3 minus -4 squared. This is going to give you 4 minus -3, that's like adding. So 7 squared plus, same thing here, it's like adding. 7 squared, 49 plus 49. And again, we're at that point where we're saying the square root of 98. So do what works best for you. In this second example, we're given 2 points and we're not given the graph. So yes, I could sketch myself a graph, but why don't we think about this a little, like how we did over here, right? So I have these 2 endpoints of CD, and I'm going to go ahead and plug it into the formula. So -4 plus 9, I'm going to average my x's, and I'm going to average, I drew a really big parenthesis, average my y's. Okay, so let's see where that gives me. -4 plus 9 is 5. You're going right on a number line. 5 divided by 2. Negative 2 plus, I'm sorry, 2 plus negative 7. That's just like 2 minus 7 is negative 5 halves. I swear I didn't even plan it for this to happen, but okay. So I'm going to leave it like that and say I've got 5 halves, negative 5 halves, right? Or maybe some of you guys might be doing 2.5, negative 2.5. That's fine. Great. So let's do the distance formula for this. And I'm going to show you, sometimes I don't, and I like to draw a triangle, so I'll show you that as well. So the square root of, I'll say that this is x1, y1. So I'll say this is my first one. So I'm going to do 9 minus negative 4 squared plus 2. No, I shouldn't be starting with 2. I should be starting with negative 7. Negative 7 minus 2 squared. So what does this leave us with? This is like adding. So that's 13 squared plus negative 9 squared. Right? Negative 7 minus 2, you're going left on a number line. So that's 169 plus 81 is the square root of 250. Which I would probably just leave like that because that's not a perfect square, but I will go ahead and show you what I would round it to. So that is about 15.811 I'll go with. If you're more of a visual learner and this isn't working for you, what I would do is I would think, okay, I'm not actually going to graph it, but I'm going to say negative 4, 2 is like right here, and 9, negative 7 is like down here, right? And I'm going to think about them like a triangle. Ooh, the triangle's got to connect, doesn't it? Okay, so I'm going to think about it like a triangle, and I'm going to say this is D and this is C. It doesn't really matter. What is my change of X? How do you go from 9 to negative 4? Like, what is that gap if I was looking at a number line, or if I am looking at a number line, right? To go from 9 to negative 4, that change is actually 13. So that horizontal change, that change of X is 13. What about from negative 7 to 2 on a number line? Well, that change of my Y, to go from negative 7 to 2 is going to be 9. Right? And then I could go ahead and I could say, oh, I'm just going to use the Pythagorean theorem now and do 9 squared plus 13 squared equals CD squared. Right? Which ultimately is still going to get me to this point, right? I'm still going to have 13 squared plus negative 9. Like, it's still the same thing. I'm still going to get 250. But if you're more of a visual person, that idea might work for you. Fantastic. Let's turn the paper over and let's do some more examples together. If you want to pause the video, or if you want to try this on your own, I encourage that. I think that's a fabulous idea. So distance. I'm going to do it as a right triangle. 1, 2, 3, 4. 1, 2, 3, 4. That's boring. So 4 squared plus 4 squared equals, I'll call it C squared because I don't know what else to call it. C, right? So that's going to give me 16 plus 16 equals C squared. What is that? 32 is C squared. So C is going to be the square root of 32, or approximately 5.657 I'll go with. What about midpoint? Let's write down these coordinate points. Let's use a new color. -1, -1. And this is -5, -5. So average, -5 plus -1 divided by 2. -5 plus -1 divided by 2. Right, so -5 plus -1 is -6. And they actually both are that. So I end up with a midpoint at -3, -3. Right, which makes sense. Check that out. That's definitely dividing it in half. And then I just wanted to include slope. It's a little bit silly because I'm looking at it as a segment, but let's say like this segment is part of a larger line, a line that extends indefinitely forever in both directions. So to find slope, I'm going to use the idea of rise over run. So I'm going to be going, oh, I already have it written, right? Up 4 over 4 4 over 4, so this would have a slope of positive 1, just to not forget that scale. So along some similar lines, now I'm given 2 points, I'm going to find the slope, the midpoint, and the distance. I'm going to go backwards because that's the order I did it in before. So I'm going to go with the square root. Let's say x1, y1, x2, y2, 7 minus negative 8 squared, plus negative 2 minus 5 squared. What is that? 15 squared, because that's like adding, plus negative 7 squared. So that's 225 plus 49, which is the square root of 274, which is not a perfect square. So I would leave it like that, but I know some of you guys want it rounded. Or you could say 16 points, let's say 553, or whatever you round to. I usually do 3 decimal places. Midpoint, average, 5 plus negative 2 divided by 2. Negative 8 plus 7 divided by 2. So 3 halves. Negative 8 plus 7 is negative 1 half. And I'm going to leave it like that. It doesn't simplify. If you want to write 1.5 negative 0.5, fine. And then the last one is slope. And if you remember, you were doing the change of y over the change of x. So y2 minus y1 divided by x2 minus x1. I'll just go how I already have it labeled. So 7 minus negative 8 divided by negative 2 minus 5. So, and we already have a lot of this, right? So 7 minus negative 8 is going to be 15 over negative 7. Doesn't simplify, so there's my slope. I just realized I did this in a different order, right? The formula technically says x1 minus, or x2 minus x1. It won't matter because we're adding them, so I did the y's before I did the x's. That's my fault. But good to notice that it doesn't matter because you can add in either order, right? 4 plus 3 is the same thing as 3 plus 4. Let's do a little bit more difficult practice, or some different variations of it. So given one endpoint at negative 1, 9, and there was one like this in the video, and a midpoint of negative 9, negative 2, find the other endpoint. So we have the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2 equals the midpoint xy. Right? So let's go ahead and let's plug in. So I know that endpoint. So I've got negative 1 plus something divided by 2, and 9 plus something divided by 2, and that's going to equal negative 9, negative 10. What I like to do is set up like these mini equations. So negative 1 plus x2 divided by 2 is going to be negative 9. And then I can solve that, right? I can use my algebra, times 2. Negative 1 plus x2 is negative 18. Add 1, x2 is going to be negative 17. Right? So I have my x-coordinate now, negative 17. Let's do the same thing. I did not leave myself nearly enough room to do my other value. Let's set up another mini equation right here. 9 plus y2 divided by 2 equals negative 10. So with these, they have to be equivalent. Times 2. 9 plus y2 equals negative 20. Subtract 9 and you get y2 equals negative 29. So that is actually the other midpoint. So I set up 2 mini equations. I'm going to do another one, don't worry. Am I? I'm going to do one like that. Oh, maybe I'm not. It's okay. So given one endpoint at 5, 2 and a midpoint of negative 10, 2, find the length of the entire segment. So I'm going to go ahead and I'm actually going to find the distance between the endpoint and the midpoint. And then what do you think I'm going to do after that? Times 2, right? It's going to be double. This is going to be half the length of the entire segment, right? This is half, like, this is the midpoint of it. So that's going to be halfway. So let's go ahead and let's find that distance. The square root of negative 10 minus 5 squared plus 2 minus 2 squared. Oh, that's nice. They're on the same level. Right? My y's are the same, so they're the same y value. It's just going to be a horizontal line. Negative 15 squared, that's just 0. So this is going to be the square root of 225, which is 15. Right? And then we're going to take 15 and double it. So the length of the entire segment is going to be 30. Okay, a few more. So given one of the endpoints is P and one of the endpoints is Q, determine the point that's a quarter of the way, 1/4 of the way from P to Q. Right? So here, well, 1/4, I want to take a segment. So I've got P and Q. If I want to figure this a fourth of it, I have to split this up into fourths. Right? So I want to know what is this point right here. So I want to know you're going to do half of half. Right? So I need to start off and get this. Right? What's this? Right? What's the midpoint of PQ? Well, 2 plus 10 divided by 2 and 4 plus 8 divided by 2 is going to be 12 divided by 2 and, oh, also 12 divided by 2, isn't it? Yeah, so you're going to have 6, 6. This point right here is 6, 6. What was P? 2, 4. So now I want to figure out, like, I don't even care about this anymore. I want to figure out what is halfway between P and this new point I just found. Right? So I'm going to now do 2 plus 6 divided by 2 and 4 plus 6 divided by 2. So that's going to give us 8 divided by 2 and 10 divided by 2. So that's going to give us 4, 5. So a point that is 1/4 of the way from P to Q would be that. What if I had said, or what would my question have been if I wanted you to find this point? This point is 3/4 of the way from P to Q. Right? So I could have asked that question as well, and that would have been, you would have then taken the midpoint 6, 6 and found what is halfway between 6, 6 and 10, 8. Okay? Okay, let's look at the last one, which is a real application. Like if you're don't feel like you're there, that's fine. You can stop the video if you'd like, if you want to try to follow along with me. This is a challenge because this is combining a lot of stuff that we've done and you've done, which I know is hard at this point because we're not sitting at school. So given the endpoints of a circle's diameter are -4, 4, and 5, -1, determine the center and radius length in order to write the equation of the circle. So I'm going to go ahead. If this is, let's see. I've got a circle. It's a beautiful circle. And I know the endpoints, right? I know this is, and I don't know exactly, I'm not graphing it truly, -4, 4, and I know this is 5, -1. Well, how do I figure out this point? Well, that's just midpoint, right? So -4 plus 5 divided by 2 and 4 plus -1 divided by 2. Well, that's going to give us 1/2, 3/2, right? That's going to be the center. How do you find the radius? Well, if I find the length of this right here, and then I can cut it in half, right? Oh, that's a distance formula. So I can say the square root of x minus x. Let's do 5 minus -4 squared plus -1 minus 4. Right? So minus a negative, that's 9 squared plus, what is this? -5 squared. 81 plus 25. What's 81 plus 25? 106. You know what? Why don't we go ahead and round that? Let's say it's about 10.25. I'll go with 10.3 just to make this simpler in our heads. So that's what we call the diameter. So if that's the diameter, what is the radius? Well, 10.3, and if you have it left in your calculator, just leave it and divide by 2. So 5.2, 5.15. Some of you guys might be leaving this as the square root of 106 and then doing the square root of 106 divided by 2 and just leaving it like that, right? So that's fine or that's fine. And then this we have for the center. So then the final piece of this is maybe you remember how to write the equation of a circle. X minus h squared plus y minus k squared equals r squared. So let's go ahead and put that in. So what do we have here? X minus 1/2 squared plus y minus 3/2 squared equals to this number squared. I get 26.5 when I square that about. Yep, 26.5, right? So that is the equation of the circle, right? So you guys have been working with this, and maybe this is familiar to you because you did it with circles, right? If this piece of it was over your head, it's fine. If you're like, hey, I could get midpoint and distance, but this application really threw me, you're good. I just wanted to add it in there for some fun math. So what we just did in this lesson was we used some of our prior knowledge about algebra and solving equations, and some of the information we already had about midpoint and distance in order to use and apply the midpoint and distance formula. So I would encourage you at this point to use the extra practice worksheets and the online practice to support your understanding of this topic. And thanks for watching.